Hello, welcome back to the channel. So let's do a different kind of question, which is also based on the properties of definite integrals. So we'll use some properties of definite integrals that we already covered in the last video. So if you have not watched my previous videos on the properties of definite integrals, I would highly suggest you to first watch those videos in order to get the full context of this question. And you can also see those videos on the I button above. So let's go over this question. So in this question, you have been given fx and gx, which are two integrable functions, and you've been given the area under the curve for some given endpoints as well. So you have been given the definite integrals based on different endpoints, and based on the given information, you have to calculate this definite integral. So now let's start with what we have to calculate in this question. So we have to calculate a definite integral which is based from x equals minus 1 to x equals 2. So I know that I have to take a definite integral starting from x equals minus 1 to x equals 2 in this case. And based on the given information, I can see that for fx and gx, I have those definite integrals which are based from 0 to minus 1 and 0 to 2, and if I can somehow flip this endpoint, I'll get the definite integral from minus 1 to 0, and if I combine minus 1 to 0 and 0 to 2, I'll get the integral for 0 to 2 by using all the properties of definite integrals. So this is the approach that we will use in this video in order to calculate this definite integral. So let's start with what we have to calculate. We have to calculate integral minus 1 to 2 3gx minus fx and this whole dx. If we simplify it down, it would become, let's break both of these functions by using the sum property of definite integrals. So it will become integral minus 1 to 2 3gx minus integral minus 1 to 2 fx dx, and it has a dx as well over here, right? And now let's take this 3 constant out in this case, so we can have gx dx and fx dx in our definite integrals. So if we do that, we'll get 3 times integral minus 1 to 2 gx dx minus integral minus 1 to 2 fx dx. And now we want this and we want this, right? So let's calculate both of those definite integrals individually in this case. So if we start calculating the integral of minus 1 to 2 gx dx, it would become integral minus 1 to 0. If we have to break it on 0 point, on x equals 0, it will become minus 1 to 0 gx dx. And remember, that is done because of the question need, because we have been given that the definite integrals are broken at the point x equals 0. So that is why we are breaking this definite integral at x equals 0 in this case. So that would become integral minus 1 to 0 gx dx plus integral 0 to 2 gx dx, right? And now let's notice what we have been given for gx. So we have been given that the integral from minus 1 to 0 and 0 to 2, and that is what we have over here. So we have all the information about gx. So now let's solve for this. So integral of minus 1 to 0 is 3 in this case. So this is 3 plus integral of 0 to 2 is 4. So this answer is 7 over here, right? Now if we calculate the integral of minus 1 to 2 fx dx using the same property by breaking it at x equals 0, it would become minus 1 to 0 fx dx plus 0 to 2 fx dx. And now again let's check for what we have been given for fx. So instead of minus 1 to 0, we'll notice that we have been given 0 to minus 1, and it's easy to calculate 0 to 1 as well based on minus 1 to 0, right? I can use the second property of definite integrals that we covered in the last video, which is flipping those endpoints. So if I flip those endpoints, if I take the definite integral from 0 to 1 in this 0 to minus 1 in this case, it would become minus of 0 to minus 1 fx dx plus 0 to 2 fx dx, right? And since we know both of these expressions, let's use those expressions. So we know that 0 to minus 1 is 1 and 0 to 2 is 2. So 0 to minus 1 is 1 and 0 to 2 is 2, right? And now this fx dx from minus 1 to 2 would become 1 in this case. So now since we calculated this expression and this expression, we can use this to calculate our final answer as well, which is based on this expression. So now based on all the given information, if we evaluate this expression, we will get 3 times minus 1 to 2 gx dx is 7. So 3 times 7 minus this expression is 1 in this case, right? So 3 times 7 minus 1, which is 21 minus 1, and that is 20. So 20 is our final answer, and that is also the answer for this definite integral. And you can clearly notice that in order to calculate this final answer, we only use the properties of definite integrals in this case. So that's it for this video. I hope you found this video interesting. Please follow the channel in order to get notified about the other videos that I'll be uploading. Feel free to comment down in this video if you have any doubts related to this video or any other doubts as well. Stay tuned. Thank you so much for watching. Bye-bye.